Hello guys, how are you doing? Okay, so we are going to start what we're going to work on for the rest of this week, and we're certainly getting close, aren't we, to the end of this chapter, and for you all, the end of this school year. So today we're going to solve polynomial equations, and we will be doing this primarily by factoring, but I'm going to also show you more about using synthetic division to your advantage. Now, a few tips on solving polynomial equations, which you can see on your skeleton notes. You always are going to start by moving everything to one side on the left and putting equals 0 to the right. Carry the equals 0 part throughout your work until the bottom step, and that's when you'll actually say x equals 4, x equals 1/2, that kind of thing. Okay? You're going to go to completely factored form on every problem. Never, ever, ever divide out a letter. If you do, you'll lose answers, and I'll show that in just a minute. You're going to identify double and triple roots, which is to identify the multiplicity of a root. We'll talk more about that. Write the factors of double and triple roots as like x minus 1 quantity squared or x plus 4 quantity cubed. That will help you when we get to graphing. It also helps you identify, oh, that's a double root and that's a triple root because that factor's squared and that factor's cubed. Alright, so I mentioned that you should never ever divide out a letter. You can always divide out numbers if you want to make the whole equation seem simpler, but don't divide out letters. So some people might see the equation I have here in blue. Solve x cubed minus 3x equal to 0. Well, number one, it already has everything on the left with 0 on the right, and that's what you're supposed to do with it. But sometimes people start doing what you see in red, which is incorrect. So they'll add the 3x to the right-hand side, and then they'll say, well, let me divide both sides by x. And when they divide both sides by x, they bring the equation down to x squared equals 3. Then they'll say x equals plus or minus the square root of 3. Well, they've got 2 of 3 answers. And you might say, well, how do you even know there's supposed to be 3 answers? Guys, this is the beauty of polynomial equations, and it's actually called the fundamental theorem of algebra. If you look, once you get everything all cleaned up where everything's on the left and equals 0 is on the right, the degree of the left-hand side will tell you you're going to get this many answers. So I can see from the original blue equation I should have 3 answers. Well, on the red equation I only have 2, so somehow or another I lost an answer. Well, the green way is the right way to solve the equation. They've left the x cubed minus 3x on the left-hand side like they're supposed to. When you factor out the GCF, you get x times x squared minus 3. X squared minus 3 does not factor further. And so you just say that the little factor x equals 0 and the big factor x squared minus 3 equals 0, which means x squared will equal 3, and then x equals plus or minus the square root of 3. So you do have 3 answers. X equals 0 is one answer, and then x equals square root of 3 is one answer, and x equals negative square root of 3 is one answer. So those are your 3 answers. All right, so notice on the blue equation I have on this slide, I've got it written correctly because I have the x squared, the x minus 5 cubed, and the x plus 1 to the understood first power. You don't need to write that first in. But what that's telling me is my x squared is going to give me a double root. My x minus 5 to the third power is going to give me a triple root. And then my x plus 1 to the first power will give me a single root. The other thing is when it's in factored form, like I've got it, you can tell the degree because you say let me see if I can get it to right where I mean for it to. 1, 2, 3, 4, 5, 6. So in factored form, if it's in descending form, you look at the highest exponent. In factored form, you add the exponents of each of the individual factors, and that gives you the degree. So if the degree is 6, you're going to get 6 solutions. That's the way you read that. Okay? So you'll see here that I've used the word roots. Remember, solutions, zeros, and roots are interchangeable terms. And then they also are basically interchangeable with x-intercepts, but we'll talk more about that when we get to graphing. So to just say x squared gives you the answer 0, and x minus 5 cubed gives you the answer of 5, and x plus 1 gives you the answer of -1, that's incorrect, okay? Now, you could say x equals 0 and 0 for x squared. X equals 5, 5, and 5 for x cubed. X equals -1, and that's it. Just -1 for x plus 1. And then you have 1, 2, 3, 4, 5, 6. You could write it out like that if you wanted to, but you've got to be clear about what all the answers are. So you'll see me write it the way I've shown you in green. If 0 is an answer twice, I call it a double root. If 5 is an answer 3 times, I call it a triple root. And then if -1 is an answer once, it's a single root. Normally I don't write the S's by single roots, but if I write a D or a T, then you know it's a double or triple root. If there's nothing beside it, it's understood to be a single root. But that way, when you count, you can see it's 1, 2, 3, 4, 5, and 6. I should have said 1, 2 on the 0 part. So that's going to be really important because when we graph, the way you're going to graph a double root looks different from the way you graph a triple root, and that looks different from the way you graph a single root. So we got to get our duckies in order now. All right, so here we go, guys. Let's go ahead and solve some equations. Now on number 1, everything is on the left side like it's supposed to be with equals 0 on the right. I need to remind you that when we're factoring, we always start with GCF. I do see a GCF, and when I factor it out, I get x squared minus 9. Now, I see that x squared minus 9 might still be factorable because it's a quadratic and it's a binomial. So I've got to keep trying. Well, if I've got two terms, the first thing I need to do is go, wait, is that a difference of squares? If that doesn't work, I need to also say, well, is it a sum or a difference of perfect cubes? Well, it's a difference of squares, so I'm going to factor it like it's a difference of perfect squares. Remember, difference of perfect squares is my favorite factoring. I've got it completely factored. All of my factors are understood to be to the first power, so I'm only going to get single roots. So x, you just set equal to 0. X plus 3, remember you can set it equal to 0 and then solve, but it's also completely reasonable to go straight to x equals -3. Ditto, on the x minus 3 factor, you can show that you're setting the whole factor equal to 0 and then solve, but most people just go straight to x equals 3. Well, I see 1, 2, 3 single roots. Well, that's right, because I can tell I was supposed to get 3 roots because that was the degree of the original equation, which was in the descending form, the descending order or standard form. Now, same thing goes on number 2. It's already in the correct descending order, and so I can tell I'm about to get 3 solutions. So remember, you go back and you say, well, GCF always is first. I do see a GCF, it's x. And so now I've got x squared minus 3x plus 2 equals 0. Don't forget that. You carry it to the very, very end until you say x equals 0 and x equals -3 and x equals 3, like how we finished up number 1. All right, so I see that I still have a quadratic factor because I have an x squared factor. I can see it's a trinomial, and trinomials tell me try AC method. Well, when I look at it, I'll do my scratch work down here at the bottom. When I look at it, I see that A is 1 and C is 2. So let me see. If I start to break that up, I know the only way I could do it is 1 times 2. Okay, hey, look, since the B is -3, If I change it to -1 times -2, then I in fact get +2, and -1 plus -2 equals -3. So yeah, I've got it now. I can tell that I should make it x on the outside. I'm going to go to brackets here. X squared minus 1x minus 2x plus 2 equals 0. So x squared minus x groups. You're going to have a GCF of x times x minus 1. Bring down the minus sign in between. 2x plus 2 groups, or negative 2x plus 2 groups. But I see I'm going to pull out the 2, and it better be the x minus 1, right? Because I have to have matching x minus 1s for grouping to actually be working. I get negative 2x plus 2, which does match what was on the original step, so I know I'm all right. Here I get x squared minus x, which matches what was on the original step. So I'm kind of checking as I go. Inside the brackets, I can make that x minus 1 times x minus 2. And then remember, you're fine like you are, but you can also, now that the inside is totally factored, everything is in bundles that you're multiplying, you're more than welcome to drop the brackets. So do you see that I get x equals 0 from the first little factor? I get x equals 1 from the second little factor, and I get x equals 2 from the third little factor. That's 3 answers, and that's what I anticipated. Let me remind you of something, guys. Shortcuts. If you have a 1x squared, you could potentially skip these 2 steps. Only if you lead with a 1x squared. Because notice, I said I needed -1. Well, I see x minus 1 there, and a minus 2 tells you you've got x minus 2 right there. So if you lead with 1x squared, you can make that shortcut. If you lead with 2x squared, 3x squared, or anything else, you need to do the steps because it doesn't work out that way. I'd like for it to, but it doesn't. But there is a shortcut that you can employ if you have a 1x squared trinomial. All right, so take a look at number 3. Number 3 is actually not a higher order cubic, but this would be something that sometimes catches people off guard. The left-hand side's in factored form, but the right-hand side equals 5. So the factored form doesn't help us at all. So you need to start on the left-hand side by using FOIL method. So first is x squared. Outer is minus 2x. Inner is plus 2x. And last is minus 4. Now, I'm also going to subtract the minus 5 over and put it equal to 0 so I can get this puppy cleaned up. So I have x squared. Hey, look at this. The plus and minus 2x's cancel out, and now I've got minus 9 equals 0. Oh man, that's going to be an easier problem than I thought. I thought it was going to be another trinomial I had to clean up. So this is not a higher order, so to speak, because I can tell it's just quadratic. So I'm going to have 2 answers. And on the quadratic, if you factor completely, if there's just 2 terms, is this a difference of squares? If not, check sum or difference of cubes. But always start with what you knew first. Check it first. It is a difference of squares. So I'm going to factor it. That's my favorite factoring method. I think it's the easiest to spot and the easiest to implement. I knew I was going to have 2 answers. I've got 3 and -3. Those are my 2, so I'm going to boogie forward. On number 4, it's not where it needs to be, so let me rearrange. I'm going to put the I just now realized I wrote to the 6th. Sorry about that. Don't know where that came from. Asleep at the switch, I guess. Let me bring the minus 5x to the 4th over and put it in the middle, and then the plus 4x squared, so that I've got my polynomial in standard form, which is descending order with your exponents. Now I can tell that my degree is 6, so be prepared. We're about to have 6 solutions. Okay, so here we go. First things first, always GCF. And I do see a GCF of x squared. times x to the fourth minus 5x squared plus 4. Whew, okay. Now I see a quartic and x to the fourth polynomial on the inside. So that means I need to use the AC method on the inside. So notice my A is 1 and my C is 4. So of course my AC is 4. I'm being a little bit more thorough on this one, just in case me doing shortcuts on the last one kind of bubbled you up. My B is -5. Hey, it's going to work out a lot like it did a minute ago, because one option is 1 times 4, or the other option is 2 times 2, right? But when I recognize I need them to add up to a negative, I know to switch both of them to a negative. -1 minus 4 will give you your -5. -2 minus your 2 will give you a -4. That's not what we want. Now look, guys, it's 1x to the fourth. So I could take the shortcut. So bring your x squared. I'm going to make a big gap because I'll go in and add this stuff in just in case you're not comfortable with the shortcut. But I know x to the fourth has to be x squared times x squared, so that when you multiply back out using FOIL method, you get back to x to the fourth in the first term. Don't forget your equals 0. Now, I'm saying it should be -1 and -4. Since it was 1x to the fourth, I can make that shortcut. Now remember, if you don't feel comfortable with the shortcut, then you're going to say, let me write x to the fourth and use the -1, -4 as -1x to the second minus 4x to the second plus 4 equals 0. X squared times, I'm going to group these two, factor out an x squared. That's going to leave you x squared minus 1. Bring down your minus sign. Group these two. I see that a 4 should factor out. I better be left with x squared minus 1 or grouping doesn't work. Double check. X to the fourth minus x squared. That checks out with the previous step. Minus 4x squared plus 4. That checks out with the previous step. And then can you see that you go from my second blue step to my last to my black step again? Can you see that you do that on your own? Now, are we done factoring? No. Take a look. These quadratic factors need to be factored again if possible. And do you see that both of them have two terms so that you check difference of squares? And both of them are a difference of squares. My favorite kind of factoring. Did you think I wasn't going to give you a lot of these? So I am factoring a difference of squares on both of them. Now we said you should have 6 answers. And I just realized that I dropped my squared off. Oops. So here are my 6 answers. X squared tells you, since it's a squared factor, that I get a double root. And the double root would be x equals 0 double. Then the x plus 1, x minus 1 tells you that you're getting -1 and +1. Let me condense it into plus or minus 1. And the x plus 2 and x equals negative, or x minus 2 tells you you're going to get x equals -2, x equals +2. So I'll do plus or minus 2. I have a stray dot that I didn't mean to be there. But if you look at it, guys, you're going to count it 1, 2, 3, 4, 5, 6. So I've got 6 roots. I get 0, 0, +1, -1, +2, -2. That's 6 total answers. All right, we'll take a look at this one. So everything's where it should be on the left with equals 0 on the right. And so I'm supposed to check for GCF next. I don't see a GCF on this one. Now I count terms and say, oh, there's 4 terms. Well, what kind of factoring goes with 4 terms? Grouping. Yeah. So we can go straight to grouping. So I group the first pair. I see that 4x squared is a GCF. So I'm going to make it x plus 10. Double check that. That's 4x cubed. Check. Plus 40x squared. Check. Bring down the minus sign in the middle. When I look at x and 10, nothing factors out, so I'll just put a 1 there, and I'll change it to x plus 10. Remember, if you've got x plus 10 here, you got to have x plus 10 there. We'll double check that. Distribute, negative 1 times x is negative x. Negative 1 times 10 is negative 10. So life is good. Things are where they're supposed to be. I'm going to rewrite that as x plus 10 times 4x squared minus 1. Now, the first factor is linear. Linear factors never go again. But the second factor is quadratic. Quadratic factors might go again. They may not, but they might go again. So if they do, you've got to keep going, because it's one of your tips was to factor to completion. You always have to factor as far as you can factor. So do you see that 4x squared minus 1 is in fact the difference of two squares? Don't act surprised. You knew I was going to be putting more of these things in here because it's my favorite kind of factoring. So 2x times 2x is your 4x squared, and of course 1 times 1 is your 1. Now I've got it all equal to 0. I'm done factoring. It's time to answer. Can you give me your three answers? If you've said negative 10, negative 1/2, and positive 1/2, you are correct. If you chose to write it as plus or minus 1/2, that's fine. No, wait a minute. That's only three answers. Something feels wrong. No, no, no. Everything's fine. My original equation was in factored form, or in standard form, excuse me, and it was had a degree of 3. Hey, by the way, once you're in factored form and you've got to the first, to the first, to the first, remember, if you're in factored form, you can add all those little exponents, and that'll give you the degree. So it's easy to see your degree, whether the equation starts in standard form or whether you might be given factored form. Sometimes they'll give you a real super easy one on the computer. Sometimes, not all the time, but sometimes. Okay, so couple more direct factoring problems. So take a look at number 6. I see that the degree is 3. So I've got to find 3 answers. So x cubed minus 8, I'm looking for a GCF first. I don't see one. Okay, so then I'm looking and saying, okay, there's just 2 terms. So is it a difference of perfect squares? No, x to the third is not a perfect square. So is it a difference in this case of perfect cubes? Yes, it is, because x cubed is clearly a perfect cube. And remember, 8 is a perfect cube because it's 2 times 2 times 2. So I got a little bi-tri-soap action going. So the cube root of x cubed, recopy the minus sign because that's same. The cube root of the 8. So I need same, opposite, always positive. And remember, in the first slot here, I say first squared. In the middle slot, it's first times second. In the third slot, it's second squared. Now, on these guys, the second or the trinomial part never factors again. And let me go ahead and prepare you. The trinomial part is always going to give you weirdo answers. So the first one gives you x equals 2. That's nice. Some people think it's going to give you x equals 2 as a triple root, but it won't. Okay? They want to say that x cubed minus 8 is the same thing as x minus 2 cubed. Well, that's not true because that's not using bi-tri-soap. But this would give you 2 as a triple root. This gives you 2 plus 2 other answers. So those are not the same thing, but beware because that's the common mistake. People want it to be easier than it is because then it doesn't take as much time. But that's not going to work out the right way. All right, so let me go back and tell you again. The trinomial part won't factor again. That's just, you don't have to do AC method and see if it won't factor. Okay, so don't waste your time. The other thing is whenever you get a quadratic that doesn't factor again, you are going to get messy answers. So messy answers means that you're going to either have square roots in the answers, i's in the answers, or both. So let's see what goes on there, okay? So I am going to have to say I have this quadratic x squared plus 2x plus 4 equals 0. I need to find the answers, but I can't find the answers by factoring. So how else do we solve quadratics? Well, you can do complete the square, or you can do quadratic formula. Since 2 is even, let's do complete the square because it's been a while. So remember, you're going to say 2x plus space. When you complete the square, you actually move the plain number to the other side. So remember, when you complete the square, leave the x's on one side, the plain number goes to the other side. And I want to remind you, this is going to be x plus. All right, so step 1, take half of the 2 and get 1. That's what goes here in this step right there. Step 2, square the 1 and put it there. Step 3, add the 1 to the other side. Step 4, add negative 4 plus 1 and get negative 3. Okay, that's your complete the square technique. Now you've got the x plus 1 squared isolated. Remember, why do we do complete the square? Because it sets us up to take the square root of both sides of the equation. And don't forget, when you take square roots of both sides, you introduce the plus or minus. So now I've got to do two things. I've got to move the 1, and I've got to clean up the square root of negative 3. So I'm going to say negative 1 plus or minus the square root of 3i. And remember, if you want to write it negative 1 plus or minus I square root 3, you most certainly can. That's an option. In fact, a lot of people like that I first. A lot of times that's what I think you'd more likely see on the computer. Okay, so let's check out number 7. And do you see, by the way, on this last problem, just to re-emphasize, you were supposed to get 3 answers, and your 3 answers are 2. That's really not where I meant to put that. That's all right. But 2, negative 1 plus the square root of 3i, and negative 1 minus the square root of 3i. So you did get 3 separate answers. I just want to make sure that you all know to count negative 1 plus or minus the square root of 3i. Count that as 2 different answers. All right, so here we go. On the next problem, number 7, I've got to get everything to the left. So 5x to the 4th minus 4x to the 4th is 1x to the 4th. 11 minus 20 is going to be minus 9 equals 0. I see it's a 4th degree function. It's a quartic, so I'm going to get 4 solutions. There is no GCF. There's only 2 terms, so I start with difference of squares. It is a difference of squares. So I know x to the 4th is x squared. I know I've got a plus and minus, and I bet you see that I've got 3's. All right. So now, guys, both of those are quadratics. I try to factor them again. But on the quadratics, like the second one is not a difference of perfect squares, so it doesn't go again for sure. And neither of them is perfect cubes. And so you're done factoring. So I want to say again, if you've got quadratics that won't factor again, and both of them are in this boat. Sometimes one will and one won't. But if you've got quadratics that won't factor again, expect messy answers. So messy answers means answers that have square roots in them, answers that have i's in them, or answers that have square roots and i's. Either way. So I'm going to say on the first factor, x squared plus 3, what you technically do is say, well, let me make x squared plus 3 equal to 0, And then also let me make x squared minus 3 equal to 0. So isolate your x squared on both of them. And now do plus or minus the square root of both of them. So I get the square root of negative 3 just like I had in the last problem. And the square root of positive 3. So that's going to give me plus or minus the square root of 3i. And just plus or minus the square root of 3. So messy answers have square roots or i's or both. So my first two messy answers have both square roots and i's, and my second one just has square roots. So don't be completely alarmed. You're not going to get a lot of these messy answers, but you will get some. So don't be completely alarmed by it. Also realize sometimes the question won't ask for all the answers. It'll ask for the real answers only. And if it does, sometimes that question will pop up on the computer. The real answers are just the two square root of 3 and negative square root of 3, those two only. So sometimes questions will ask for just the real answers. I tend to ask for all of them. All right, so on these last few questions, we are going to use synthetic division to get us rolling. Now, if you look at the problem that I'm giving you, the equation, you might go, oh, okay, well, I don't see a GCF. There's 4 terms. I'm going right into grouping. And when you go into grouping, you're going to say, well, in the first 2 terms, x squared is my GCF, and I'm going to have 3x minus 2. Then I'm going to bring down a minus sign. And what goes into both 121 and 280? Well, I know 11 goes into 121, but 11 doesn't go into 280. So my GCF is just a 1, I guess. So I would have 121x and then minus 280. But wait a minute. Since this 121x minus 280 doesn't match that, grouping is not working. Okay? So you generally need something different. Like if you try grouping, it's for grouping problems is when we start to pick up this new method. If you start out thinking they're going to group and they don't group, then you have to go, oh, I'm going to have to use synthetic division. Well, right now in this lesson, we're always going to be nice to you because we're going to give you the problem or the number that you start doing synthetic division with. So I'm telling you x equals 5 is the solution. I could also say that x equals 5 is a root. X equals 5 is a 0. I could also say x minus 5 is a factor. On all of those, I'm giving you the same basic information. So you start and say, oh, well, if I have one answer, I can use synthetic division to get me on my way. So 3, negative 2, negative 121, 280. Remember, the first thing you do is bring down the 3. Now, it's been a couple of days, so let's review, and I'll get my handy-dandy marker out. I don't know how well it'll show up on the gray background. But you say 5 times 3. Do that diagonal multiplication is 15. Add straight down. Negative 2 plus 15 is 13. Now you're going to do diagonal multiplication again. So 5 times 13, I believe that is 65. Negative 121 plus 65. I'm referencing my calculator to make sure I don't make a boneheaded error on the video here. I'm getting negative 56 when I just add these straight down right like they are. I'm going to do diagonal multiplication. So 5 times negative 56. Now I'm keeping my fingers crossed. I'm doing this on my calculator. 5 times negative 56 does turn out to be negative 280. And I know that this is a remainder and that the remainder must be 0 if, in fact, 5 is a solution. So that tells me, okay, I'm doing okay on my synthetic division. Now, guys, the next step is to go, oh, if 5 is one of my solutions, then x minus 5 is one of my little factors. So then I get a little factor times my big factor. Well, this is the ones place. x's place, x squared's place. So I start out with 3x squared, 13x, and minus 56 equals 0. So do you see that the synthetic division got me started on my factoring? And factoring is ultimately what you want to do. So on this, I see a quadratic, so I've got to try to factor it again. There is no GCF, because if there was a GCF, you would have had one at the beginning of the problem. So you never get a GCF on a middle step of the problem if you always grab it at the beginning. All right, I need to look at AC method, I think. So let me do some scratch work over here. So A is 3, C is negative 56. So that means my AC is going to be, I think, negative 168. Let me double check my arithmetic in my head. Yep. B is going to be 13. So got to do some work here. So I'm going to start with 3 and 56. And I'll say negative 3 times 56, and then I'll switch it around. Well, negative 3 plus 56 is definitely not right. That's 53. Okay, so do you remember that if we put, and I'm going to erase this, but if you put 3 and 56 on the number line, and you say, right now, I've got 53 between them, but I want 13, then that means I need to move these two inward toward each other. So the 3 needs to be moved and get bigger, and the 56 will naturally be moved and get smaller. So there's no point in checking like 1 times 168 or 2 times, there's no point in checking those whatsoever, because now I know to go in the direction of making the 3 bigger. And remember, when I do the slider method, I'm not worried about signs because I can figure out signs later. So I'm just looking at whole numbers when I do it. Okay, so I need to try 4. Does 4 go into 168? Something tells me it does. Well, that would be 42. So if I said negative 4 times 42, look, negative 4 plus 42, I believe is 38. So we're definitely moving in the right direction. 5 doesn't go into 168. 168 divided by 6 is 28. So I'm just going up the ladder, 3, 4, 5, 6. So if that's 28, well, negative 6 plus 28 is 22. So I'm getting closer, going in the right direction. The 7 go into 168. Something tells me it doesn't. Oh, it does. I was wrong. So negative 7 times 24. So let's see here. Negative 7 plus 24. 24 minus 7, I believe, is 17. So I'm getting closer, but that's still not the right answer. Does 8 go into 168? It does. So negative 8 times, it goes in 21 times. I'm using my calculator. And negative 8 plus 21, oh, that's it. That's equal to 13. So I've got it now. Now, can I make the shortcut on my AC factoring? No, I can't. Why not? Because I have 3, not 1. So since I'm saying it's 3, not 1, that's telling me there's no shortcuts. Now, you can play around and do trial and error method. You've seen that before. But you can't just go boom and drop it into like x minus 8 and x plus 21. That's not going to work. So here I go. I'm going to start working things out. So I'm going to have to recopy my x minus 5. Let me make this 3x squared minus 8x plus 21x, and then minus 56. Right there, you could have said plus 21, then minus 8, and you might feel like that would actually make it factor faster. So I see right here that the only GCF is x, and I'm going to have 3x minus 8 on the inside. Check. 3x squared minus 8x. Here, on the 21x and the 56, I think 7 goes in. Drop the plus down. 7, I think, is the largest. I don't think 14 does. No, because 14 doesn't go into 21. And sure enough, it better be 3x minus 8 If you double check, 7 times 3 is 21x. 7 times negative 8 is negative 56. So we're rocking and rolling here. X minus 5 times, on the inside, 3x minus 8 and x plus 7. This has been a pretty long problem, but we are at the point of being done. Let me remind you, we knew there was going to be 3 answers. We now have the degree as x minus 5 to the first, not where I meant that for that to write. 3x minus 8 to the first, x plus 7 to the first, 1 plus 1 plus 1 equals 3. So whether I'm in factored form or whether I'm in standard form, I can say that the degree is 3. So I need 3 answers. If x minus 5 is a factor, 5 is the answer. If 3x minus 8 is the answer, or a factor, do you see that x equals 8 over 3? And if x plus 7 is a factor, x equals negative 7 is your answer. Alrighty, so I know you're probably going, wow, this is a long lesson, but we're going to finish up. It's not going to take too much longer. Okay, guys, so on this one, x equals 1/2 is a solution. Now I'm going to show you synthetic division. This is actually a time, though, that I think you'd prefer long division. So I might show you the long division form of this on the next lesson, because I know you're probably getting pooped on this one. But I think for some people, this is a little bit easier to explain with long division, because then you don't have to do the balancing act you're going to see me do in a little while. So if they tell me I've got a solution of 1/2, I'm going straight to synthetic, because, man, I'm going to use that solution. So I've got 2, 11, 10, and negative 8. I am checking for placeholders because that's important, and there weren't any. All right, guys, so drop down your 2. So when you do your diagonal, and you start with 1/2 times 2, half of 2 is, in fact, 1. So that goes here. 11 and 1's 12. Now you're going to do your diagonal multiplication. Half of 12 is 6. So I'm going to put that there, and 10 and 6 is 16. Do your diagonal multiplication. Half of 16 is 8. When you add, you get your remainder of 0. I knew the remainder had to be 0 because I knew 1/2 is a solution. Now, this is where it gets tricky if you do synthetic division with fractions, and this is the hardest part for students. You're going to start out and say, if 1/2 is a solution, x minus 1/2 is a factor. And then my other factor, look up here. This 2 tells me 2x squared. The 12 tells me plus 12x. The 16 tells me plus 16 equals 0. Now, here's the problem. Neither factor is correct because factored form never contains fractions. So my first factor is wrong because I've got fractions in it. My second factor is wrong because I've got 2, 12, and 16, which means there's a GCF to pull out. So this is how this works, guys. I'm going to rewrite my first factor, and I'm going to say times. I'm going to pull the 2 or the GCF out of my second factor. So my second factor becomes x squared plus 6x plus 8. Now my second factor is written correctly. The 2 that you pull out, you multiply in to the first factor. Well, that's going to make your first factor 2x minus 1. Now your first factor doesn't have fractions, and your second factor has been reduced. Now your factored form is correct, but that is a hard step for people to get. Now what I'm going to do is say I need to factor the x squared plus 6x minus or plus 8 factor. I'm going to do this quickly because I can. Okay? Since it's a 1x squared, I can go to 1x times 1x. Okay? Look, I can see that my AC is 1 times 8 is 8. and my b is 6, I bet you too can see that if you do 2 times 4, you'll get 8, and 2 plus 4, you'll get 6. So I need a plus 2 and a plus 4. I can put them right in there. Now remember, if you check that with FOIL method, first would be x squared. That checks. Outer would be 4x, inner is 2x. If you add outer and inner, 4x and 2x give you the 6x. Last, 2 times 4 is the 8. So I know what I'm doing is right because it multiplies back out correctly. Now, remember, I knew I was supposed to have 3 answers because the degree of the original problem was 3. And my 3 answers are, I'm going to move them over here since I've got not very much room over there. Since 2x plus 1 is a factor, x equals negative 1/2 is my answer. Since x plus 2 is a factor, x equals negative 2 is my answer. Since x plus 4 is a factor, x equals negative 4 is my answer. So what I might do is in the next lesson show you the same problem with long division, and you might decide, I don't like that whole divide by fraction and balance the fact. You might decide that you'd just rather do long division in a situation like that. Fortunately, since we're distance learning, we're not going to load you up with too many fractions because it's hard to explain when we're not here. All right, now I'm saying that x equals negative 1 is a 0 of the function p of x. Okay, I could also say x equals negative 1 is a 0 of p of x by saying p of negative 1 equals 0. Okay, either way, I'm telling you x equals negative 1 is a solution, so start there with synthetic division. So guys, what I really want to do is say, if I'm trying to solve for the solutions of p of x, then I'm trying to solve the equation equal to 0. Okay, so it's the same problem, it's just showing you a little bit different way that you'll see it written out. Okay, so if negative 1 is one of your answers, start there with your synthetic. So 1x to the 4th minus 1x cubed, 5x squared minus 7x minus 14. When I'm saying it aloud, I'm also double checking that I'm not skipping exponents where I would need a placeholder. Bring down 1. Diagonal multiplication. Negative 1 times positive 1 is negative 1. Add those straight down, get negative 2. Diagonal multiplication. Negative 1 times negative 2, positive 2. Add them. Diagonal. Negative 1 times 7, negative 7. Add them. Negative 1 times negative 14, positive 14. Bring down 0. Yay! Now, go to factored form. Remember, if negative 1 is a solution, x plus 1 is a little factor. Now, what about the big factor? Start, negative 14 is your 1s. That would be 7x, negative 2x squared, 1x cubed. So I'm going to start with 1x cubed. I had to work my way backward to see what exponent to start with. So minus 2x squared plus 7x minus 14. I know the x plus 1's linear, so it won't factor again, but I've got to try to factor the cubic. Well, I notice there's 1, 2, 3, 4 terms, so I'm going to try to group them. So x squared minus, or x cubed minus 2x squared makes x squared a GCF. Double check that. That would be x cubed, check, minus 2x squared, check. Bring the plus sign in the middle down. On this, I see 7 should factor out, and it should be x minus 2 if grouping's working. 7x, check, minus 14, check. So this thing groups the way I want it to. In the inside, x minus 2 times x squared plus 7 equal to 0. Now, remember the degree was 4. So I'm about to get 4 solutions, or 4 zeros. Okay? I know that x equals negative 1 is a solution. I already knew that. Now from x minus 2, I know x equals 2 is a solution. But guys, this x squared plus 7 would not factor again. It's not a difference of squares, and those are not perfect cubes. So remember, if a quadratic factor does not factor down to a pair of linear factors, then you're about to get messy answers. So what I do is say, well, x squared plus 7 equals 0, or x squared equals negative 7. Take plus or minus the square root of both sides. So I get the square root of negative 7. No, I can't leave that. So I say it's plus or minus the square root of 7i, or plus or minus I square root 7. So I really do get 4 answers. Negative 1's an answer, 2's an answer, the square root of 7i is an answer, and negative square root 7i is an answer. So you don't have to write them like what I'm writing in blue. I just want you to clearly see that's 4 separate answers. All right, couple more to go. So notice that I'm giving you Q of X format. Your goal is to solve Q of X equal to 0, or to solve 5x to the 4th minus 81x squared plus 16 equal to 0. Okay? Now, I'm giving you that Q of 4 equals 0, which means x equals 4 is a 0, because when you plug in 4, you get 0. Remember, x equals 4 is a 0 is the same thing as saying x equals 4 is a solution. So that means you start with synthetic. Use 4. So 5x to the 4th, 0x cubed, negative 81x squared, 0x, and 16. So I had to be careful on this one. Bring down 5. 4 times 5 is 20. Bring down 20. 4 times 20 is 80. Bring down negative 1. 4 times negative 1 is negative 4. Bring down negative 4. 4 times negative 4 is negative 16. I'm not saying as much on synthetic because I'm assuming that you're pretty okay with it at this point. Remember, if 4 is one of your zeros, x minus 4 is your baby factor. Work backward. Negative 4, negative 1x, 20x squared, 5x cubed. 20x squared minus 1x minus 4. Factor the cubic part. It's got 4 terms, so I'm thinking grouping. This pair has a GCF of 5x squared times x plus 4. Check it. 5x cubed, checked. 20x squared, check. Bring down a minus sign. Between x and 4, the only GCF is 1, and it better be x plus 4. If it's going to group, it's got to match the first x plus 4. Negative 1x, check. Negative 4, check. Things are good. So I've got x minus 4 times, on the inside, x plus 4, and 5x squared minus 1. I want 5x squared minus 1 to factor again, but the only option would be difference of perfect squares because it's x squared, not x cubed. But 5 is not a perfect square, so it does not factor again. That lets me know I'm about to get 2 messy answers. So remember, from x minus 4 and x plus 4, I get my 2 neat answers. Plus or minus 4 are my neat answers. I got to have 4 answers total. So from the 5x squared minus 1, I'm going to get my 2 messy answers. So if 5x squared minus 1 equals 0, I can say 5x squared equals 1. X squared equals 1/5. Now I do the square root of both sides, plus or minus the square root of 1 over the square root of 5, times the square root of 5 over square root of 5. So x equals plus or minus the square root of 5 over plane 5. So see, I did get messy answers because I've got square roots. So I've got 4, negative 4, positive root 5 over 5, negative root 5 over 5. That is 4 separate answers. Now, our last example is to say, there was an easier way to do the problem we just did. And you might go, what? Guys, when you're going through and you're solving equations, you always do GCF first. Always, always, always. Always. Okay? Regardless of anything else. Start there. Second, you count terms. So remember, if there's two terms, you're either going to do difference of squares. That's what you try first because you learned it first. If that doesn't work, you're going to try a sum or a difference of cubes. Sorry, I'm writing in hieroglyphics over here. If there's three terms, do AC method. If there's four terms, you're going to group. Grouping does work for 6 terms, 8 terms, 10 terms sometimes, but you're not going to have a lot of those, so don't worry about it. I showed you one just so you would see it for later classes, but that's not typical in this class. Then, if you've exhausted all of those techniques and those don't work, then you try synthetic. Because synthetic won't be as fast as just the regular old factoring that you know already. So if I want to rewrite the problem 5x to the fourth minus 81x squared plus 16 equals 0. If I want to solve this equation, the first thing I do is GCF. There's not one. The second thing I do is count terms. There's 3, which tells me do AC. If I did AC, I would say A is 5, C is 16, 5 times 16 is 80. B is negative 81. Guys, do you see that negative 1 times negative 80 multiplies out to positive 80 and adds up to negative 81? Since this is 5, not 1, I need to do all the steps. All right, remember, if it's 1x to the fourth, there's a shortcut. If it's anything other than 1x to the fourth, there's not a shortcut. So let me make this 1x squared minus 80x squared. So right here, x squared is my GCF. Let me double check that. That's 5x to the fourth, check. Minus x squared, check. I'm going to bring down my minus sign. 16 does go into 80. So it's my GCF, and I think it's supposed to be 5x squared minus 1. Double check. Negative 16 times 5x squared is negative 8x squared, check. Negative 16 times negative 1 is plus 16, check. So now I've got 5x squared minus 1 times x squared minus 16 equals 0. 5x squared minus 1. X squared minus 16 is a difference of perfect squares. I recognize it quickly as x plus 4x minus 4 equals 0. Guys, we already did this. This is what gave us x equals plus or minus square root 5 over 5. And then these are what gave us x equals plus or minus 4. So anyway, it's just a different way to do the same problem, and I think it's a little faster, but we were practicing on the original number 11. We were practicing using this information, so we didn't do anything wrong. I just wanted you to see that there was another way to do that problem. All right, so good luck with the practice work. I know you might need to stand up and take a break because this has been a longer lesson than normal. Congratulations for hanging in there.